In the last lesson, we saw an example of an additive inverse. And what that is when you have a rational number plus another number, if the answer is 0, those are additive inverses of each other. So if you have a number, let's say 2, and you add -2 to that number, you're going to get 0. 2 plus -2 is 0. Another way of looking at that is 2 minus 2 is 0. So what if you have an inverse of an inverse? So let's say you have the inverse of 2, which is -2, and you take the inverse of that. So you have a negative -2. Well, what the definition is the inverse of an inverse of a rational number is the number itself. So here we have an inverse, right? A negative of a negative. It's going to be the number itself. It's just going to be 2. So you can think of it as if you subtract a negative number, it's actually just a positive. So let's take a look at when this could be used. And it's mostly used when you have variables. Let's say you have a problem that says find negative x and negative x when x is 16. Okay, if x is 16, all we need to do is replace x with 16 to find a negative x and a negative x. Okay, so if x is 16, x equals 16, then negative x would equal a negative 16, which is negative 16. And then what would a negative x be? Well, all we're going to do is replace the x part with 16, right? Because x is 16. So a negative x equals a negative 16. So our answer is going to be, and remember the definition is the inverse of a rational number is the number itself. So here we have an inverse of the number. So the answer is going to be the number itself, which is 16. So the inverse of an inverse. Inverse of an inverse is the number itself. Is the number. Okay, and that's all there is to it. So what would negative x be and negative x be when x equals 14? If x equals 14 and I see an answer that says, well, what is negative x then? Well, if x is 14, a negative x would just be a negative 14, which is negative 14. So what would a negative x be? A minus x. Well, that would just be minus a negative 14, which, if you look at the definition of inverse of the inverse, it's just going to be the number itself. So an inverse of an inverse is just going to be the number itself. So it's just going to be 14. Okay, so I hope this concept makes a little bit of sense. What if I said x equals negative 5? Well, how would you do that one? If I wanted to find negative x, if x is a negative 5, then a negative x would be a negative 5, because we're plugging in negative 5 for x. So we actually are going to have an inverse of an inverse for this one. So a negative 5 would just be a 5. Now what if I wanted to find what negative x is? Well, remember, we have to plug in negative 5 for x. So we would have to rewrite this exactly the same, but when we get to the x, you have to write another -5. So it's going to be negative, negative. So far, so good. We have our negative and our negative. But now we got to the x, and we have to write a -5 for x. So negative, negative, -5. So what's that going to be? Well, right here inside these two sets of parentheses, we have a -5, which, if you look at our inverse of an inverse, is the number itself. So whatever's inside of all these parentheses, it's going to just be the number itself because we have an inverse of an inverse. But then we also have that negative out front. So it's going to be -5, and our answer will just be -5. Okay, I hope you start to get an idea of how to work with these. An easy way to think of it is if you have an odd number of negative signs, an odd number, so in this case we have 1, 2, 3, then our answer is going to be negative. If you have an even number of negatives, so like this one, your answer is going to be positive because each two negatives will cancel out and make it a positive. But if you have 3, you have 2 of them canceling out to make a positive and then another one to make it a negative again.